Today I am excited to present our work on LatentEditor, a novel framework for text-driven local editing of 3D scenes using diffusion models. Our work extends image editing applications into the realm of 3D editing, where a 3D model is trained on edited images to achieve a 3D edited scene. Therefore, it is important for me to introduce Instruct Pix2Pix, which is an image editing research work which uses text prompts to guide precise and context-aware modifications of images through diffusion-based model. In our work, a NeRF model is trained for null view synthesis to represent a text condition 3D scene. There are several applications of 3D editing, especially in media, fashion, and VR industry. Our contribution is to achieve NeRF training in the latent space to develop an edited 3D scene. In addition, our goal is to enable precise, controlled editing through text prompts, ensuring that changes are limited to specific regions without affecting the rest of the scene. Our method is not only efficient, but also doesn't need any additional control or guidance. Since we are discussing 3D scene reconstruction, let me introduce the concept of NeRF here. NeRF is a breakthrough 3D scene reconstruction technique that uses deep learning to represent and render complex scenes from multi-view images. By modeling the color and density of 3D points, NeRF enables high-quality novel view synthesis of scenes. In our framework, we first propose to do NeRF training in the latent space. We convert all images into latent features before the 3D model training starts. The model is initialized on the original unedited latents with the help of refined adapter. We also optimize the call map initialized parameters as the original posed are calculated for the RGB images and not for the latents. Now comes the editing part. Our solution is built upon diffusion models to achieve local editing in the latent space. But how do we achieve the local editing? The core innovation here is our deadlock module, which generates a mask for localized edits. This mask allows us to make highly targeted changes without compromising the integrity of the rest of the scene. The model operates within the latent space, leveraging a NeRF backbone for high-quality, efficient scene edits. Here is the more detailed functioning of the delta module, where we basically modulate the IP2P noise estimates to calculate the mask that leads to the local editing. This is a complete framework for LatentEditor, which can be divided into three parts. The first part is converting RGB images into latents. The second part is model initialization, where a NeRF model is trained on original latents with the help of adapter. And the final stage is achieving NeRF editing or 3D scene editing, where we use Instruct Pix2Pix backbone, but modulate its noise estimates using our delta module to achieve local edits. So the end-to-end framework is operating in latent space and localized 3D editing is being achieved. We tested LatentEditor on 4 benchmark datasets. In comparison to existing methods, LatentEditor significantly outperforms in terms of text fidelity and local editing precision. We can also perform multi-attribute editing with LatentEditor guided by LLM. As you can see, our method performs well in any other state-of-the-art methods. Here we are presenting some qualitative results. You can see we are not only achieving multi-attribute editing, but we are also achieving that in a more controlled way. Here we present one of our applications where we are comparing the number of training iterations with editing rate. As you can see, Instruct NeRF for NeRF requires significantly larger number of training iterations and a higher editing rate to achieve the desired results. However, our method requires less training iteration in comparison to RGB images. Here we present some efficiency analysis for our proposed framework. As you can see, in terms of GPU consumption and time, our model is more efficient. as compared to instruct nerve to nerve. With that, we will conclude our presentation. Thank you.